So that, yeah. So it is important to know that particularly the difference between population and sample standard deviation is there when the sample size is small. Once you take a large sample size, whether it is 1 by n or 1 by n minus 1, right? They will be very, very close. So it will not matter, right? Okay. So we just saw like some basic statistics. What we are doing is right now basically EDA, what Maria talked about, right? So EDA means we hear about 5-number summary. So what are those 5 numbers? Remember from stats 1, hint box plot. So when I give you a range of values of data, remember this is a Python array, right? Array containing, let's say, latitude, right? So you can think of it's a Python array containing all these elements. There are 1500 elements in array. So what are the things you can calculate of this? When I say summary, 5-number summary. So when you apply describe in a pandas column in Python, what do you get? Okay.
Is it minimum, mean, median, mode, first quartile, and no, I'm not sure.
Yeah, that's correct. Mean. Okay, mean means average, right? And I see a bunch of people putting quartiles, right? Okay. I would prefer like if you unmute and participate, I think chat is fine, but like a little bit more active participation. So yes, so that means we have already, so what we can do is we can say minimum here, right? So minimum. So what is the function I should use for minimum?
Is it min?
So most of the things should come naturally. So that's the beauty of all these functions are written in a very way. So okay, so for minimum we are getting this. Now I can drag the formula. You can quickly see what are the minimum values of all this. This is the average. Now let's do maximum also. Okay. And then what is the function I should use for maximum?
Max, I guess.
Max. Okay. Max. Now I go here. I put shift, control, and up arrow, and then right. So I get this is the maximum value. Now I drag it. So quickly you can see that all these data points, right? Particularly, is there any way I can freeze this? Because when I'm going and seeing the summary, I'm not able to refer what is column B or C or D, right? Any way I can do something which will make it easy?
There's an option called freeze pane, I think.
Yeah. Okay. So where do I get that?
Okay.
So view, freeze panes, right? Now you can do top row, you can do this, or you can do this. I chose this option, right? That is actually very useful, right? So when you have a lot of records, let's say more than 100, it doesn't fit in a screen. So it will freeze the top row, and I said also freeze the column A, right? So it freezes top row under the first column and becomes very useful. So then we are able to, do that. Okay, all right. So we calculated mean, average, and maximum, and then the standard deviation, right? Okay, all right. So now, what else we can do? We can do some charts, right? So let's look at the price. This is our dependent variable, right? So let's actually do some basic charts. So what are the charts that come to your mind? What kind of chart we should use to understand the house values, median house? Let's start our analysis with understanding the house values, right? We clearly see from the 5-number summary, the minimum price was $149.99. Of course, it's not $14,000, right? It's divided by 1,000, right? And then maximum is $500,000 or $5 million, right? So whatever that number is standardized or divided by $1,000. So what kind of chart we should do for
scatter plot?
What is it?
Scatter plot.
Scatter plot. Well, scatter plot is usually done when you have at least 2 variables, right? Here we're talking about only 1 variable. So think of distributions or charts that we can do for one variable. Okay. Somebody suggesting dollar. If we put dollar here, right? So anyway, we can do a dollar sign somewhere here. Currency. We do currency, then it will become dollar, right? And then so maybe it will be useful, right? Okay. So if we don't know, fine, no problem, right? So we just highlight all this. Then we go to insert.
Maybe a line chart, sir.
Yeah. So what you can do here is the beautiful thing is it will say chart. If you click on that chart, it will actually suggest what are the chart we can choose. And the beauty is you can actually see what is, what are the options available, right? So you can see here, if I say column, it has become like this. If we do line chart, it becomes like this. You do pie, of course, pie is not going to be good. Then bar chart, right? Area chart becomes like this. Scatter, of course, becomes like this, right? So what do we see here? Do you think line chart is making any sense? We really, can't make much sense here. If we do scatter plot, it becomes like this. So what it means is we have, our y-axis here essentially is the house price sold, and we can see that a bunch of houses that were sold, and these are basically observation numbers on the x-axis, right? So it has no order per se, right? So maybe our idea would be, okay, maybe we should sort the data, right? Look at it, what's a minimum, average, where, range, right? So that may come to your mind, right? So if we actually choose to sort the data, so let's highlight all our data sets, the entire columns. So I did that. Now, how do I sort the data? I go to data column, right? And click on sort. Now there's ascending, descending. There are multiple columns. If I do not select a column, it will sort it by the first column, but I want to sort it on the last column, column J, right? So if I go that, and here you can see I have ticked my data as header. Why? Because I selected a row 1. So that is why it becomes, I can see here the median house value, I can choose that. Let's say I want to go from smallest to largest, or I can choose from largest to smallest, right? So if we click on that, now suddenly the same data set is now going from, smallest value to largest value. So you can see here the smallest value is 15,000 and the highest value is 500,001, right? Okay, now let's try to plot it, because previously it was not ordered. Now our idea was to plot and make some sense out of it. Now again, go back to data, insert and chart, right? Do you see the change now? Let's say line plot, right? You get something like this. Pie chart, of course, doesn't make sense. If you do bar chart, the different choices you get. Scatter plot, you get this. Let's go with line plot, right? That's more meaningful. So what do you see here? How to interpret this? You want me to make it bigger?
What's along the x-axis, like prices along the y-axis and
Right.
So
along
we have got 1,500 properties. So
That's
it is
the number
going
of
from property
properties.
1 to property 1,500, right? Remember, let me show you the data, right? All of us, you also have access to that, right? So because I sorted it, now property number 1 is the least expensive property, and we have sorted it from minimum to maximum value, right? That's what we have in column J, right? So remember we studied, right, distributions, all that. So what it is showing us is some kind of a distribution of house prices, right? Okay, so if we kind of make it slightly bigger, so you can see that these many properties, anything below that is basically priced. If I put a cutoff here, right, these are horizontal, cutoff. So these many houses, anything to the left of that, all those houses were sold less than 100,000. Agree? And if I click on that, I see something called, if you see, notice the label here, it says 0.386, right? What it tells us is 386 properties were sold less than 100,000, right? Now let's see if I go to 200, right? 1235. Now this is a cumulative number, right? So that means 1235 minus 288, whatever that number was. those many houses were sold between. Now, of course, it's not very intuitive. So we know that we're getting some kind of an idea about the distribution, but it's still not getting because it's cumulative, right? We want to know some kind of a PDF, probability distribution, or whatever it is, like some kind of a marginal distribution, right? How can we do that? Any ideas how we can come up with some kind of distribution so that we can actually intuitively know? We already know average, but we also need to know the shape, how much is in a low category, how many are in medium, how many are in high, and how many are very, very high expensive properties, right? So how do we go about it?
Bar graphs?
Pardon?
Bar graphs?
Bar plots. Okay. So let us choose bar plots. I have selected the data. So let me go and okay, let me select the data again. So please guide me. You also have Google Sheet open, right? So how do I do that? Data then, or insert chart, insert chart. And then I see the bar plot here, right? Is that what
Right.
is this?
Right.
Oh, this one, 2D bar. So it gives me a chart like this.
Somebody in the chat is saying plot normal distribution.
Plot normal. Okay. Great. Basavraj, can you unmute and help me how to do normal distribution? See, first of all, we even don't know what the distribution it is, right? I know many people assume that normal distribution is very famous, but do you think the distribution is normal? How do we even know? We don't know, right? Let the data actually tell us what the distribution is. Our question here is what kind of distribution it is, right? So sometimes when you have got continuous data like this, it kind of makes sense to categorize the data, then count the frequency within its category. Would you agree? Right? So for example,
do we have option for box discount plot? So you can say what is the minimum, what is the max?
Sorry, can you, Basavaraj, can you speak a little closer to the mic? Your voice was breaking up.
Yeah, I was thinking like, can we have a box with whisker plot so that we can see the minimum, maximum, and median, so we can get to know.
Okay, box.
I'm sorry,
So box and
range.
whisker. Yeah, box and whisker will give us minimum, quartile 1, median, quartile 3, and maximum, right? Okay, so how can we, okay, so that's a good suggestion. Let's say, remember we have serial number, right? 1500 properties, right? So roughly if I want to divide them into quartile, so how do I go about it? 1500 divided by 4. So this is my, what do you call it? Like a quartile 1, right? Sorry, 1 second. So let's say I have a quartile 1. Quartile 1 I know is at 25th percentage, and then I got 1500 records, right? So record number 375 would be basically my cutoff for quartile 1, right? And minimum, of course, we know. Then quartile 2 would be, of course, double of quartile 1, right?
750.
750. Quartile 3 would be 3 times quartile 1, right? Right. And the maximum, of course, we know. Now, for us, it's actually very interesting, right? So if I create a variable called serial number here, 1, 2, I do that and double click. The beauty is if you can see that it goes from 1 to
1500.
1500.
Sir?
Yeah.
Sir, I didn't get the quartile part.
Okay, quartile part. So quartile means there are 4 quartiles, right? Quartile 1, quartile 2, quartile 3, and quartile 4. So quartile 1 means the first 25 percentile, right? So if we are sorting the data from lowest to highest, the first 25% of the data is called quartile 1. So in this case of housing data, what we did was the sample came in a random order, right? This basically was maybe we went to the property registrar and whatever the sales was happening, right? So it was happening in random order. Sometimes the low value property was sold, then the high value, then the medium value, right? So there is no specific order, right? Because that is exactly how data occurs in real life. But when you're trying to do the analysis, so what we saw was maybe we should sort the data and then plot it so we can see that. Because remember when we tried to plot the data without sorting, it was kind of going all over the place. It was not giving us a good picture. Now, when we sorted the data, we start seeing some picture, but still not very clear what the distribution should be. We kind of know that 288 properties were sold between 0 to 100,000, Maybe there are 1,000 properties that sold between, but still, we have to do a lot of deduction, and it's not very intuitive. It should show very natural distribution, right? So
Actually, sir, I didn't
Pardon?
get the multiplication part related to the quartile.
Okay, so here, how many records we have in this table?
1500.
1500.
1501.
If I want to divide 1500 records into 4 equal parts, how many I should get in each quartile? I want to divide
Around 375.
375. So 1500 divided by 4, right? That's what I have in the formula. I mean, instead of that, I said 0.25 into 1500, which is equivalent of 1500 divided by 4, right? Then quartile 2 would be basically roughly divided by 2. Instead of that, I said multiply that, but I can also say 1500 divided by 2, right?
Okay, got it. Thank you.
Yeah, then 1500 into 3 by 4, right? Okay, now that we have sorted the data, let's look at the 375. What is serial number 375 and 750, right? 375. So if I do that, this is our quartile 1. Let's highlight that, right? Quartile 1 is 9630, 96,300, right? Then quartile 2 is 750. So let's go down 750. This is our quartile 2. What is quartile 3? Quartile 3 was 1125. So let's go to 1125. Okay. Quartile 3. See, we are actually not using any box plot. There is a box plot option, but we wanted to fundamentally derive it, right? All those numbers. Once we know, we can do our own box plot, right? And of course, quartile 4 is the maximum, which is this value, right? It's kind of known, minimum and maximum, right? So this is kind of our 5-number summary, what we always say, right? So the minimum, then these are the quartile 1, 2, 3, and then the maximum, which is quartile 4. Okay, so now let's try to populate the kind of the data. So let's kind of bring it here. So let's say this is minimum, this is maximum, right? So what are the values of house price now? So minimum was 1490, right? Quartile 1 was 375. So let me go to 375. Okay, I'm just putting a reference there instead of typing it. You can see here, if I say equal to, and then kind of going back to record number 750.
J375.
Okay, it becomes J751. So I'm giving a cell reference. So if you notice here, I'm not typed. So it is actually, whatever is the natural data, the cell is coming there. So this is another beautiful thing about Excel, right? If I change the data, again, the same formulas will update themselves, right? And then
1126.
Yeah, 1125, right?
1126.
1125. Yeah, it's here.
26. 26.
26, yes. Okay, here it is. And of course, maximum is the last record, which is this one, right? Okay, very good. So now we have some idea, right? So we are getting like 5 values. So this is roughly 15,000. So what it tells us is, between this and this value, we have got 25% of the properties. Between 96,000 and 139, we have 25% of the data, right? Now we're getting closer. We're kind of understanding that if we divide 100%, 25% of the data is between 14,000 to 96. Another 25% is between 96 to 139. 139 800 is median price, right? Which means roughly half of the properties got sold less than 139 800, and half of the properties were sold above 139. Right? Now let me tell you this: we calculated average, right? So if I remember, our average was 151,930, right? 151. Here the median is 139 or 140. So here median is less than mean. So whenever you find a distribution where median and mean are different. Can you call the distribution symmetric?
We can't.
No, we
No.
can't.
No.
And one of us suggested that let's plot normal. Do you think, based on the evidence we have seen, do you think it is going to follow normal distribution?
No, it will not.
No.
It will be like skewed either to left or right.
Correct. Great answer. So Basav, I think you had a question about normal, right? Now we already are seeing evidence that is not symmetric, right? Okay. Now still we haven't created the distribution. If I plot all this, all it is saying is, my bins are like spaced. To find a distribution, I have to have equal size of bins, right? So now we'll talk about how to create histogram out of this data, right? So there is a trick. So what you can do is, we know the minimum value is 15,000 and maximum value is 50,000, 500,000, right? So, okay, 15,000 and maximum value is, okay, actually it's here, right? Sorry. Not how many bins we should create to get a nice distribution? 20 bins, 30 bins. So imagine I want to do a distribution, right? Because I want to categorize it. We should have a little bit of more number of bins so that we can see a very nice and smooth distribution, isn't it? Right? So we are going to hand create all those distributions. We are not going to use any formulas or anything. Let's actually understand how to do this, right? Just using Excel, right? Using the data we have got. Let's say, how many bins should we go for? 20 or 30 bins?
Let's go with 30.
30, okay, 30 bins. Now we know this is the mean and max. And if I want 30 bins, what should be my bin width?
Okay.
I take max minus
Min.
divided by 30.
Hmm.
So this should be our bin width.
Yeah.
Okay. All right. Can I do something that, okay, my minimum is, let's say, 14.99, right? Then my bin one, whatever it is, will be this plus, I put F4, right? Because I don't want the formula to change, right? Then you can see here, if I drag, you can create that, right? Bin 30, 31, like that. And then if you see here, notice second bin will be first bin plus the bin width, F4, right? So
Right.
what it's telling me is what should be the cutoff or line markers. Do you see here?
Hmm.
So basically I can prove that it's correct. So if I want to now calculate how many records are between, less than. So I can always say, let's say less than, right? So I want how many are less than that. How do I actually efficiently do it? Any idea? We know what the bin, yeah.
Is there a function called countif where you can like count the number of values in a particular
Very good.
thing?
Frequency.
Yeah, very good. So let's say I do this, okay. So I say countif, right? Okay, countif. So I
So
say,
actually, I have a question about the initial part. How do we decide on the number of bins?
we see, this is again a choice. We know that because we had only 4 bins, right? We could not find out a distribution, because in a 5-number summary, we only got 4 bins, like quartile 1, quartile 2, quartile. So we know roughly 25%, but we are not really understanding the distribution very well, right? So what we said is, no, maybe our bin was variable, the frequency was constant, right? That's what we got in a 5-number summary. Now we kind of changing the question. We are saying, no, we want to understand the distribution. That means I need to fix my y so that way I can count my frequency on the y-axis, right? So in order to do that, I need to fix my bin width. So the real choice is, what should be my bin width? We don't know, right? So in order to get a clue, we took the minimum value, we took the maximum value. So I got my range. Now it is chop it into equal pieces, right? Now, question is, we can go 20, 30, 40. We know that generally, if we have more number of bins, and when you count, it will basically become a very smooth distribution, right? But if we do too much, then it will be very choppy. If we do too little, then we won't get understand. So it is kind of it's not fixed or set in stone. This is where I think some amount of thumb rule is 20 or 30, but depending on the data and its distribution, you may have to change that. Yeah.
So for smaller data sets, if you have less number of rows of data, we cannot
Then-
use a lot of bins, right?
So
Because
you
that
reduce it. Then you reduce it to 5 or 6 or 10, right?
okay.
Between about 1500, roughly we are saying we'll have at least 50 on an average.
Can I say that if we choose a lot of bins for a small data set, that'll be overfitting?
Not overfitting, you're basically basically going to see all the noise. You will not see a nice smooth distribution. Yeah.
Okay.
Because we're not changing the data or we are not building the model. There's no overfitting. Right now, we are not even doing any modeling. We are only trying to understand data. We are still in exploratory data analysis phase.
Okay.
Yeah.
Thank
Vasaraj, you
you.
have a question? You have a hands up?
Yeah, instead of like guessing the number of bins, can we like take the square root of the total number of points? Like we have a 1500 points, and if you take a square root, I'm not sure how much it is, then
Okay.
just
Let's say square root function SQRT, and then I put 1500. I get 38.
yeah. I'm not sure. Like I'm just asking you, is it a good practice?
I mean, what you're saying is if you've got n number of data points, you're saying your bin width should be square root of n. I mean, I think different people use different thumb rules. But remember, if I give you 1,000,000 rows, would you create what is million? Let's say you are dealing with 1,000,000 rows, square root of million will have how many zeros? 6 zeros, right? 3, 4, 5,
Yes, sir. 6.
yeah, 1,000. What does intuition tell us? Do you think we should have 1,000 bins?
No, it doesn't make sense.
Doesn't make sense, right? So usually 30, 40, 50 is a good number, right? Irrespective of the number of size of the data. I think I just want to make sure that while it may be okay a thumb rule, but I think again we have to kind of see after 30 or 40 it will be very quite a play. Umapati, you have a question. Go ahead, please.
Sir, my suggestion is can't we have 20 bins?
So Umapati, first question.
20.
I'm also a student like you, so you can call me Debasmit. No need to call me sir. The only sir is Sudarshan sir, right? We are all students here. Yeah. Go ahead, please.
Okay. So I was about to ask whether 20 bins will suffice because we already have the quartile details. We have divided into 4. So 30 would mean almost 6 or 7 in one quartile. If it is 20, then there could be some probably meaningful conclusion. In a quartile, we will have 4. That is only a suggestion. So
you are suggesting 20.
yeah, 20.
Okay. All right. So should we create a poll? I don't know. I mean, how to create a poll here, but let's. Yeah. Anybody wants to create a poll? Or otherwise, let me. Okay, fine. Yeah. Give us some time. Solution. Yeah. Okay. All right. So we have learned that a thumb rule of 30, if you remember sample size 30, then it's considered good, and then 20 is also fine. We can actually try both, right, Umapati? So let's try with 30 first, then we'll reduce it to 20. Yeah. Okay. All right. Acha, somebody is saying, okay, wait 1 second. Okay. All right. So how many bins we chose? 30, right?
25 is also a good idea
Yeah.
because going by the quartile, you'll have 5 each.
Okay. I think, we can take any multiples of 4 or 5. Doesn't matter. I think beyond once we cross 20, 25, 30. So these are all what I call as just matter of personal choice, right? So if the data is large, it doesn't matter. Like, once you cross 20, you get a nice distribution, right? So in case of data analysis, there's no right or wrong answer, 20 or 25 or 30. In some context, 20 may be fine because you have a smaller sample. In a large sample, you can go for 30, not a problem. So this is where I think we as a data scientist have some kind of a liberty, right? So it's not like accounting where the rules are fixed, right? So this is very exploratory, right? We're going to explore, change few things, and then kind of we are trying to understand the data, right? So let's we decided 30. Let's go with 30. If we don't get good results, then we'll reduce it 25, because now we know how to calculate the bin width and all that, right? So is there any efficient way we can actually calculate? Somebody suggested that COUNTIF. If I do COUNTIF, right? How do I go for it, right? What is the, it says range and criteria, right? How do I go about it? So for example, if I want to count how many are less than 1400, right? COUNTIF, then it says range. Range means the entire distribution, right? Then what else? Next, criteria. Criteria is less than 15,000. Do you think it will work? Yes. Now let me.
You want the number of observations in the particular bin, right? So
Correct.
criteria is different, I think.
The criteria is basically the condition.
Yeah, so you have to give the first between minimum and the bin one.
Okay, so let's go to the bin one, right? So now the bin one criteria is, let's say COUNTIF, right? Okay, now I have to give the range. If you see here, it says range, right? So my range hasn't changed, right? Range is always constant, which is J2 to J1501, and I'm going to put F4 here. So that way the range is always constant. Now the criteria is what?
The first one will be between the min and the bin one. Second one will be bin one and bin two.
So how do you do that?
Okay, you can use cell referencing for that, right?
Cell reference. I mean, I want to
Dollar.
count. Huh?
We use dollar symbol.
Dollar symbol. Okay, all right, dollar, and then what else?
Fixing the value.
So I've already fixed the range here, if you notice here, right? So anytime you see here, COUNTIF range criteria, right? So range is this, which I've selected. Criteria means whether it is greater than or less than, right? So what I should do? I should say what? Say greater than 1499.
Yeah, and less than whatever the value was under bin one.
How do you
Because
do
you
that?
want the
How do I give less than greater than in one?
and, right? Logical
And is like
no,
this. And,
capital A and D. Oh, no, this one, yeah.
capital A and D, okay, and then less than.
I'm actually not sure about that. Yeah, and then less than.
31,166.
Yeah.
Okay, let's see. Do you think it will work?
Instead of hard coding the values, can't we just use cell referencing for after the greater or less than sign?
Good. Thanks, Nirbhav. Right. So I want to make sure that, we obviously, that it's going to be painful, and every time the data changes, then we have to hard code, and it's going to be very, very time consuming, right? Actually, that is the point I wanted to prove, right? So that's why we created all these bins. So now we know like how to even, make it a bit. Okay. So one of the suggestion was, let's not type these conditions and all that. What I want to do is COUNTIF. I'm saying greater than what? Instead of 1499, I want to give the cell reference greater than N12. Anirban?
Yeah, yeah.
And then what else I should do? And less than
Less than
this.
Yeah.
And double quote and close.
Yeah.
Like 0.
I don't know if you drag it down, it's going to fit in automatically with the others or not.
Correct. It will fit. The formula is changing N12 and N14. But the problem is I'm getting only 0. Okay. So there are many things. We now know these are the bins we want, right? Is there any way I can convert these values into the bin? I don't know what the bin is going to be, right? So this is where we'll learn something called your table and all that, right? So if I know, so okay, maybe let's go back to fundamentals, right? Let's say I want to create the bin number I want to take a value, do something to it, so it will give me the bin number. Can I do that? Then it will be very easy, right? So let's say I give you this, right? So we know the minimum and maximum. So if I take the number, subtract the mean, and divide it by the bin width, will I not get my bin number?
Yeah.
I can, right?
You will.
Yeah. So let's actually, that's a trick actually. So let's say I take this number minus the mean. Mean is this one, right? Right? And divided by the bin width. Bin width was? What is the bin width?
16167. Yeah.
So
Okay.
is it not going to give you 0? You are
It is bin 0. Okay. Now if it is Python and all that, but let's do one thing. I'll do 1 plus. Right.
instead of J2, we can do what is that? 09, I think.
Okay. Okay. So, but okay, the first answer is correct, right?
Mhm.
If I want to take this formula, Control C, right? Then paste formula. Second one is also N, because remember what we said, the first bin goes from 1499 to 31,000, right? So let's now kind of drag the formula, right? Okay. Now you can see here, like 25,000 is getting assigned bin 2. Is that right? 25,000 minus 15,000, for 15,000 will give me around 10,000. 10,000 divided by 16,000. So anything going on here? It's not correct, right? So what can we do to change the formula here?
I think we did in the formula we did J3.
Yeah.
Sorry, what did J2? Yeah, we took J2 minus 05, right?
No, it is actually a floating. If I take integer, because remember this is giving me a ratio, right? If I do just the integer, now you do it. You see that? Because when previously when I was doing that, it was continuous 1 plus, the moment it exceeded 1.5, it was getting rounded to 2, right? The moment I changed, okay, you take the difference divided with the bin and take the integer value, right? So then it became like this, right? And then you kind of drag, and if you can see here, notice the moment it exceeds 31,000, it becomes bin 2. Just pay attention to the formula here, right? What is happening here? 1 plus, forget about the 1 plus, right? Just look at J7. J7 is 32,000 minus the minimum value, 14,000, divided by the bin width, right? And it is going to become, so if you really want to verify that, so let's say I want to take this value, 32,500 minus 1499. What is the value? 17,501. And if I divide 17,501 with 16, okay, and then put like it's getting 1.08, and then I'm adding 1 to it, right? So this is why it is becoming this. The moment I change this formula, J7 to, let's say, I drag it and move it up here, J6, if you notice, it is 0.93. So you can see that once you change the number, the ratio changes and it exceeds 1, and 1 plus 1 is becoming 2, right? You can see this is where that means all these properties now will belong to bin 1. These properties will be part of bin 2, right? So now I'll actually keep counting the instances of 1 and 2, right? So it is going to be very slick now, right? So you can see here, if I drag, the formula is getting updated. You see magically now this 47,000 becomes bin 3. You see here? Right? I mean, I think the way we did it is bin 1, bin 2. If I do that, I think you can see here like 30 bins, 31 bins will get, right? So it doesn't matter, 30, 31, it's basically going to give us more or less that distribution. Let's do that actually, right? So if you notice here, we started with bin 1 and we ended with bin 31, right? Okay, now each record has been assigned to a bin. Can I aggregate and group the data by bin? Yes, no? Somebody was mentioning about pivot table, right? We're going to learn about that now, right? So how quickly can we summarize the data? So if I select everything, let's say from column B to column K, select everything and go to data, go to pivot table. Okay. And I'll put it in new spreadsheet and click OK, right? So what you see here is this is a very powerful tool. What a pivot table means is it's going to allow us to aggregate raw records into summary records, right? So what you do is here you see 4 boxes here. Filters means if you want to do this only on a subset of the data. So let's ignore this. The most important thing is rows and columns, right? So remember we're going to do distribution. So we are only going to bring which variable? We're going to bin, right? So I'm going to put it on rows. So you can see here it goes from 1 to 31, right? Now I want to count the number of houses. What will I do? Let's say this median house value, right? If I put it by default, it will do sum, but I right click, go to value, and then select count. Right? Are you following me?
Yes.
If I do that, suddenly I have the count of houses that got sold in that price range. Now let's look at this data.
This is a frequency distribution that we are getting, is it?
Correct, correct. So remember in the first table, what we got is we first count, kind of created 30 bins by hand, then assign the bin number. Then using the bin number, we are now summarizing. So essentially we are counting. So we actually saved ourselves a lot of the hassles, right? Remember count if and all that is pretty painful, right? And depending on data, but with this approach, it can change. Now somebody was suggesting let's do on 20 bins, not 30 bins, right? Now you see using this formula, it will be very easy to do that, right? Okay, any suggestion how to do it more efficiently? You see what is happening in the R9. R9 is the bin width, right? Right?
Right.
Okay. Instead of that, R9, you will say whatever is the max value and min value, right? So max value is this one, right? I'll put a F4 minus the mean value. Mean value is
5
divided by 20. Will it work? We'll find out soon. Let me just paste formulas first. Okay. It's not. We have to put one more bracket here because it's getting multiplied on the numerator. That's why. Put one more bracket and do this. Do you see that? Now you may argue that why it is becoming 1 and 20. So maybe what we do is we do -1. So if I need 20 bins, I can do into 19 here, right? Because I'm doing 1 plus, right? 1 to 20. Now let's go back to the pivot table that we had created, right? Okay. So this is our raw data. Let me rename the data set. This is raw data. And this is the summary. Now, if you notice, if you right click and refresh, what happened? You see here 1, 2, 3, 4 like that, right? It just the bins and then number of count. Now you see the duplicate is coming in here, right? So let me just take care of that. Let me delete this and do it again. So because only one column was selected, right? So we have to select the entire column, right? So if I start with longitude, latitude, and the recalculated bin, I go back to data, pivot table. If you notice here, I'm going from column B to column K, right? Click OK. You can see the data came here. And after that, what should I select? 2 rows. Anybody? Bin, right? I do bin. Then I count the house values. By default, it gives sum. Go on in pivot table, I select count. If I do that, what do I get? You see that I'm getting now only 1,000 records. Any reason why it is happening? Anybody wants to say? Because remember we said we had to do integer, right? That's why. Because it's creating floating point, and that after that it is the real number is getting rounded off. If I select that, I'll still get 1 to 20. Go back and refresh. Change. You can see it goes from 1 to 20, and let's move it to all the way to the end. So you can move to the end, right? So that way it's sorted. You can see here this, right? So now let's take this data. I can copy everything up here, the 1500 records. Now I paste special as values. You can see I've been 1 to 20. Now this is the count. Let me plot the data. Insert. What should I do? Line chart? Line chart. Interesting. So I can say axis title, vertical axis. This will be number of houses. And x-axis will be, so if I
Pins.
so right click, you can do many ways. Like there is actually, if you drawing tools or home or chart, there are a lot of options you'll get, like chart tools. You go to chart element, go to axis title, and primary horizontal axis, it will come, and this is basically the bin, right? So now if I say this, so this is just a frequency distribution, right? How do I convert a frequency into PDF? Just divided by the total frequency, right? That's what you learned in start one, right? How do you convert a frequency chart? So if I know my total, this is 9 divided by 1500 is the total number. Okay? Let's keep it up to 2 decimal points, right? If you see here, notice sum. We learned that sum of the probability distribution is actually 1, right?
Right.
So it is indeed a PDF. That probably you would have got it in a quiz, like add up all the probabilities. If it is not 1, then it is not a PDF. So are we sure that we actually got the PDF and the probability distribution? Right? We did not use any Python. We got everything done from fundamental first principle, how to use Excel to generate, find the PDF of our dependent variable, right? Now we found out, is it looking like a normal distribution now? Basavaraj, I think your question was, can you do normal? Do you think it is normal?
No.
No, right? Okay. So in some cases we may find it. So, but this is a quick way of doing an exploratory data analysis, doing the distribution. Now, whatever we did for Y, you can pretty much do the same for other variables as well, right? We saw how we can do the 5-number summary and the distribution and all that, right? Now, of course, we did basic EDAs. What you had covered today was how to calculate minimum, maximum, quartile one, percentile, and the basic EDA, right? How to calculate average, standard deviation. We found out the data is skewed. You saw that the mean and median, they were not the same. You can clearly see the right tail is a lot longer than the left tail, right? So it is skewed distribution. So what it tells us is a lot of properties are selling in the low ticket, and after that there are very lot of high-end properties, particularly if you go to near headquarters of Google like Mountain View and all that. These are all very expensive properties in the Bay Area, right? So this is exactly what happens in California. You will see, if you look at what are those properties, you'll see latitude and longitude. You go to Google Map, you'll see very close to headquarters of Google and Apple, those the smaller areas, which is the heart of Bay Area, right? Real estate is all about, if you buy a property in the city center, it will be more expensive, but if you go to the outskirts, it will be slightly less expensive, right? Of course, these are all advanced areas, but point is the data distribution actually tells us what the how the price. So if you have a property, the location, then you can actually estimate the price at which the person should sell the house price, right? Now, of course, this is still, we just scratched the surface, right? We want to build a model. We have not even, so we learned how to do the binning and histogram, right? And calculate the PDF. The next question is now I want to get into the predictive business. So before you get there, I want to stop here for a second and see if anybody has any kind of questions, comments to share. Anyone?
You guys can raise your hands if you have any questions.
Yeah. Otherwise, we'll go into the prediction business now, right? Okay, now we want to do regression. So how many of you have actually done regression, have an idea about regression? Raise your hand. Okay. We talk about linear regression, very simple. Okay, good to know. Okay. Only 4? There should be more, right? You have 42 people here. Okay, very good. All right. Looks like a lot of people haven't done regression. So maybe one of you who has done regression, would you like to explain what regression is and how it can be, how it is a useful tool, particularly if you are trying to learn from the pattern and use it for any kind of prediction? Folks who have done the regression, the old timers, I know your name, so please unmute yourself and, maybe explain to the rest of the audience how regression can be a very useful tool, particularly in this kind of problem.
I may try, but
Yeah, go ahead. Yeah, go ahead, please.
So when we have like X and Y data, and the Y is like, here is the value of the house. So it is like continuous variable. So when we have X and Y, like our Y particularly in a continuous thingy, then we will go for a linear regression. And linear regression works like as X moves and also Y moves. So it comes with the coefficient like it's the formula of straight line, like Y is equal to mx plus c, and X is nothing but here our observed value, and B is nothing but we are going to add some bias or the constant value, and we are going to find out the coefficient. So this coefficient will be used, the coefficient we are learning here for the observed data, and when we do a prediction, these coefficient will be used for the predicting the new observed values, like whatever.
So in the very, very good answer. So in this data set, we have got how many variables? We have got, so these are all hypotheses, right? So if we are the data scientists, this data was given to us, right? Let's go back to the raw data, right? So if I go to the header, so J is my dependent variable. So let's highlight that column J. This is what we are interested to predict, right? Okay, so let me put it in green color, right? This is what we want to predict. But I have data from column B to column I. I can use one of them, let's say, right? If I have to choose one, which one should it be?
Maybe we need to find the correlation before we do
very good, right? Modeling. So you want to know a variable which is highly correlated with the Y, and that will be the best candidate. Okay. All right. So how to calculate correlation? Let's do that, right? So if I want to, maybe I want to insert a row. So let's say correlation. So what is the formula for correlation? Covariance by variance, right? So, but don't worry about it. There is a correl function here. If you notice here, it says RA1 and RA2. That means give it 2 column vectors, it will calculate the correlation, right? So one of the vector is the J vector, right? Column J. So I select everything and put a F4 because this is not going to change, right? So this is my first array. Then I put a comma. I fixed it. Remember, I put $. So that means that Y is always fixed, but I'll kind of keep changing the X, right? So my first X variable is column B, right? The longitude. And I selected shift down arrow. So basically, if you notice, it gave negative 36. So what does it mean?
Sorry, can I ask a question, please?
Yeah.
Why didn't we fix the second array?
Because You'll see in a second. If I did the formula, I copied over to the next cell. You see what happened here? I'm comparing J versus B. Then I'm going to do J versus C. Then if I drag here, now I'm doing J versus D. So J is not changing, but I'm dragging. Then B, C, D, they are changing, right? So if you notice here, right? So let me drag all the way here to I. So if you look at the formula here, the first cell is comparing or doing the correlation between J and B, right? If I go to the next.
Clear. Got it.
Yeah.
Thank you.
Okay. So this is basically a trick. So when you're playing with Excel, you need to understand what you want to fix. My Y variable, dependent variable is fixed. So you will put an absolute reference there. They're putting F4 will give a dollar number. If you don't know, then if you don't remember, put a dollar for the column and rows. Okay. All right. So now based on this, what do you see here? Interesting, right? I plotted the correlation as a bar chart, right? You can notice here
Median income has
the column I, right? So maybe I should put the select data and then put the labels here. The labels are here. Click OK. Okay. So what do we see here? Let's
median
put
income has strong correlation.
our data labels. So this is beauty, right? So you can clearly see which variables are highly correlated. What do you see here? Median income.
Right.
So that means if people have more money, they can buy more expensive houses, right? Kind of makes sense, right? But of course, households or there's more population, they are positive. If there is a more dense area, then looks like it more demand and then the price is going up. So then if there are more bedrooms, the price is higher, kind of makes sense. But it's positively correlated. If there is more total number of rooms, bigger the house, higher will be the price, kind of makes sense, right? So these are all variables where if the value increases, my dependent variable or the house price also increases. Kind of makes sense, right? So this is one of the things you as a data scientist should look at it. Now let's look at all these other things, right? Housing median or longitude and latitude, right? Remember longitude and latitude, right? So these are basically geographic locations. So California is kind of goes from, it's kind of a rectangle goes from north to south, right? As you kind of go down, like you go from, Northern California to Southern California, the bottom part is LA and San Diego, Bay Area is in the middle, right? So as you kind of go down, you will see more expensive properties are there, right? That's basically, but remember it's geography, so I'll not read too much into it, but these are all intuitive, right? If a house has more rooms, it will be more expensive, right? If it has more bedrooms, it will be more expensive. If the population, if you're going from a rural to urban area, like more population or more population density is high. But more important thing is the income is looks like very strong predictor of house price, right? So now what we will do is, now that we have done correlation, we'll pick the variable with the highest correlation and we'll build a simple linear regression where we will say house price is a function of total median income. Okay. All right. So if that is the case, okay, how would we do regression here? I don't know. Anybody wants to guide me on that? How to do linear regression in Google Sheets or whatever it is. I can do it here. Let's go to Google Sheets, right? Right. We have the same data in Google Sheets, right? Median house value and all that, right? The sorting of the data is not important, right? For regression, it can be in any order, right? So I want to build a model, right? So how do you do linear regression? Oh, I just type LI. I got the answer, right? Do you see here? Linear estimator. It says best fit linear trend via least squares. So what it means is I'm actually, before even I do anything, let us actually do a plot between median income and median house, right? So if you see here, I select these two columns, select everything, insert a chart and a scatter plot, right? Yes. So I'm using Google Sheets now, right? All of you, I think I've shared that. So you can see here, what do you see here? If you see here, do you see a pattern here? Yes, no?
Yes.
Do you see that as the income increases, house price also increases?
Right.
And there's a trick also in scatter plot also, if you right click here, right? Chart area, chart style, all that, right?
Strong
That
positive.
range. You get all this choice, right? Chart style, you can change. A lot of customization is also available, right? But let's say, we want to now actually find a relationship between these two variables, right? So let's go up. So the scatter plot looks like here it is. Now I want to do regression, right? So what I want to do is linear. I said when I type regression, it is called best fit linear trend via least square. What does it mean? Like to the scatter plot, right? Let's take a look at it. Right? Okay, let me cut it and move it to the top. So it is. Okay. It's here. Okay, so I want to fit a straight line through this. When I'm saying a relationship, right? I can try to fit a line. Now, remember, I can put any n number of lines, right? I can go like this. I can go like this, right? But how? We want to make sure we fit a line through these points. So that way, all these points should be close to the line. Now, of course, the points are scattered, right? Our job is to kind of fit a line through the data. So that way, the distance between this point and the line is basically called the error for each individual point. And when you add up all the error, or some errors are on the positive direction, some are in the negative direction, right? So we want to kind of ignore the sign. So if you square it, so it will give us the error of the square of the error. Then add up across all points, right? How do you know if you want the best line, not just any line, right? Because I can draw a line like this, or I can draw a line this,
When
or I
it's
can
squared
draw a line
error,
like this, right? Yeah, go ahead, please.
Minimize the error.
when you have squared error as the minimum, you
Correct.
that's the best.
Right. So essentially, think of it as like if I fit a line and calculating the error, then I am adding up all the squared error and I want to get the minimum, right? So you can randomly guess, right? So we can actually randomly guess what should be the intercept and slope and all that, but there is a regression equation. Do you want to do random guessing, or we just want to use the formula and get it, right? So for example, if we want to use the formula and get the equation, we'll have to still prove that we actually got the error, the least error. Let's say this is a linear estimator. What did it say? Known data y. Right? It actually hints us, gives us a hint, right? Y means that my predictor variable. So I select this vector, right? So 15 data points, then give a comma, then known data x. Known data x would be this. What else I need? What output did I get? 35, 125, 32, 433. What does it mean?
This is just a
Slope and
guess. I'm assuming it's the y, like
MNC.
slope and the y-intercept.
Slope and intercept.
So K is, what is the intercept? What is the slope?
Okay.
K is, I think, slope, and L is the intercept.
How do you know? Is there any, so if you do a help function, will you, I don't know if F1 will work or otherwise help, right? Function list, right? If you do here, function list, sometimes if you don't know, you just type linear estimator. So all I'm trying to show you is when we don't know using a new tool, you need to know how to go to the help function, right? So if you go there, it says known data y, known data x, calculate b, verbose, right? You can do that. If I do that, it says, okay, appendix B of blah, 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 right?
Maybe in
So
the
what
learn
does it
more
give us?
section, sir.
Hmm?
Maybe in the learn more section.
Pardon?
Learn more section.
Learn more, okay. This is the syntax. Okay. First one is a coefficient. Second one is a y-intercept. Right? And then it says you wanted to give the verbose. So maybe one option we did not give was verbose, right? So what do? I type verbose. So we'll get a lot of information. Oh, wait a second. Anything mistake we're doing?
I think it has to be true or false.
True or false? Okay.
Yeah.
Just calculate B. Then okay. All right. Cool. Thank you. There's one more option also. False, true. False is not calculated B, true is verbose. Okay, fine. Don't want to calculate B. Let's try from scratch. Right? So we'll say linear estimator. These are the Y. Then we need to give X, which is this. Right? Then we don't need B, but we need verbose output. Okay. No statistics, right? There is an error, it is saying, right? So let's look at our output, what the documentation said, right? It says known data Y is a two-dimensional array, known data Y is one-dimensional array, right? Two, then it should be same. Ours is one-dimensional array. Then known data X may represent multiple independent variable in a two-dimensional array. Okay. Now known data optional 1, 2, 3, so basically here it is expecting the B means the intercept, right? We actually want the intercept. So we should go back and try to do intercept. And then it says use multiple variables. So we, instead of using one variable, let's use two variables, no problem, right? Remember we did a correlation. We can select two variables, right? Or we can do all the variables actually, in fact, latitude, longitude, everything, right? Let's do that, right? So linear estimator of this. Now this time I'm using all variables, not just the latitude or longitude. I'm using. So should I? One thing is like, should I include the header row? Then it will be more informative, right? So let's keep the header and see if it is intelligent enough to find out. Then it will be output will be more intuitive. Okay. Then we select everything X, right? So we are now selecting column A to H. Then we definitely want B. B means the intercept, and verbose is also 2, right? So we are giving both the values. It's giving error. This is actually telling us something, right? So it's saying linear estimator parameter 1 expects number value. That means the header is not working. So I know that I have to start from row 2. Row 2. Okay. Then what is saying? Expand if it could not overwrite a data in M2. There's a data in M2. Okay, maybe some hidden data is there. Let me clear it out. Okay, maybe this scatter plot is coming in the way. Okay, now you can see. I think I'll just redo it because a lot of things. So let me start from scratch. So if we are trying to do a regression, I'm saying linear estimator. First, I had to give the Y. Y meaning the dependent variable. So I start from the numeric first record to the last record. We can see I2 to I1501. And give a comma. Then I have to give all my X data. X meaning the independent variable. X variables will start from latitude or longitude actually. Longitude, latitude, housing, all the way to median income. And then I go down. My last record is 1501, right? Then I want the intercept and I want verbose output. Okay. So what we get is actually the output of typical linear regression. So if we go and look at our documentation, look at what we are getting is, this is the regression coefficient and it's the intercept, right? We can give 1, 0, or we can give 1, 1, right? I think you can give 1 or a 0, or you can give true or false. It basically like a Boolean, right? So what we see, okay, how do we get the description? Single independent variable, multiple.
It's mentioned below.
Yeah. Okay, so coefficients are x2 and x1, and then the standard errors are also given, right? So let's look at our output, right? So first column is all the coefficient, and these are the standard deviation, right? So how we interpret is, the equation is basically nothing but 31,846 plus 1158 times our first variable, second variable, third variable, fourth variable, like that. Is that right? So if I go back and read, so in this case, the data was basically y, and there are two independent variables, x1 and x2. So you get x2 and x1 intercept, I mean the slope, the y-intercept. So you get 3 output. So if you got 2 variables, independent variables, you get the output 3. So in our case, how many variables we had? 1, 2, 3, 4, 5, 6, 7, 8. 8 independent variables. I don't think we got how many? 2, 3, 4. How many we got? Total 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see that? The first row is basically all the coefficients. So this is our first is intercept, and these are all the slopes for each variable. Right? So we can actually test it out, right? So we can code the model, right? So if I say my prediction is, let's say I call it prediction, right, of the model. So this is my intercept plus my coefficient for the first variable. What is the first variable? Latitude, right? Plus this is the coefficient of the second variable, which is latitude. Now I used L and M. Now I go to N. This is the coefficient for the edge. Is there an efficient way to do that? Of course, there's a dot product, but anyway, let's do in a simple way first. Then I go O times, which variable I should change? Total rooms, right? Then I choose O. No, O has been chosen now. After O, I choose P. 511 times total bedrooms, right? Plus Q times population plus
R times household.
R times household. Okay, I think I made a mistake here. It should be F2, not F2 actually, because I have to take the data, not the header, right? So I have gone up to Q2 into F2. Then after Q, it is R times G plus S times
H2.
H. Okay. So this is our equation. Do you see here what happened here? The prediction became negative 399, right? Now let's actually see how. Okay. So one thing I have to notice here is, remember this K, L, all these things have to be fixed, right? So K has to be fixed. So I put F4. Then L has to be fixed. M has to be fixed. So I'm selecting that and pressing F4. O has to be fixed. P has to be fixed. Q, R, and S. So this is the O number. And then if I drag it below, you can notice the formula repeats. So if you can see here, L and M, all these, whatever I put $sign, they are not changing. But I go, oh, wait a second. I actually, yeah. And then this is becoming 3, right? 3. So as I go to the rows, it is changing, right? Okay. Let's double click. Yeah, all the values are coming negative. I think we made a mistake in how it was showing intercept and all that, right? If I do not give the intercept 0,1, then it is giving me this. So there is a what do you call it? I think mistake in the formula. So let me actually do one more time. This time I'm not going to use intercept. Linear estimate of I. Let me only use 3 variables, not the entire thing. I'll just use population, household, and median income. Let's keep the model simple, right? Only 3 variables. Okay. And then I don't need intercept, but I need verbose. Okay. So you get this. But if I don't give even that, I get only the coefficients. Do you see that? This is actually easy to code, right? So if I go back to our whether calculate B means the intercept and verbose, I said no. But if let's say I want to have intercept but no verbose, so what I do is I go here and I want intercept. So calculate B is the intercept. You can see here, now the intercept is here, last, right? So let's go back to the documentation. It says in our documentation, learn more, right? Here, intercept is the last one, right? And it is going from x2 to x1. I think it is going in the reverse order, right? So we should, I think that was also another mistake we made, right? Now it is very clear. So I have to now write down here, this is x1, this is x2, and this is x3. Let's actually try it out, right? So prediction, what I'll do is I'll remove all this. So what I'll do is I'll say, okay, this is the intercept, which is f4, plus this is the coefficient for this multiplied by, what is my x1? I used only 3, right? So it should be household, right? Then I should use this coefficient. Then I want to pick it constant and I'll pick the income. Sorry, I made a mistake here. I'm using F and G. So F is, let me give the name here, insert one more. Because I'm using in my formula, right? F to H, F is my X1. Okay. G is my X2, median income is X3. Okay. And this is my Y variable. So if that is the case, this is according to the documentation, this is X3, X2, and X1, and this is the intercept. Okay. Now let's use the formula. First, I have to do intercept, and it is going to be constant. So I put F4 here. Then I have to use the slope for X1. Slope is constant. So I put dollar times X1. X1 is this one, right? Plus the slope for X2. So I'll put a dollar because I don't want to change it. And this is variable. So it will be G3 plus, let's say, this one times X1. X1 is what? Okay. NM
L3.
L, right? L3. But I want to put it on F4. Okay. All right. So what you see here is the predicted value is coming out to be 91. Okay, let me put, let's get rid of the decimals actually. Okay, now let's drag this formula down. Okay, Control C. Okay. Control V. You can see here now, this is my prediction. This is the actual, right? Now let us do a scatter plot between my actual versus what the model predicted, right? Insert, then a chart, then it was scatter plot, right? Let's look at it. What do you see here? Is that right? Very similar to the original scatter plot we had done, right? So as you see this is not a model value, right? Actual also looked like that. So looks like it's kind of giving me, similar error I saw in the original scatter plot, right? So how do you know how good or bad this model is? Is there any way you can find out? My prediction is good. My prediction, I can find a correlation between prediction and actual, right? Is that right? If I do correlation between this, sorry. I do correlation between column I and column J.
Strong
So what do we get?
correlation.
72. Now remember when we did a correlation, if you remember we did a correlation, right? So let's revise that, right? Remember we did the correlation between each independent variable and the dependent variable. Let's revisit that, right? So correlation between, this is my first variable, comma, the dependent variable, okay? Close. Remember I had to keep the dependent variable constant, so I put F4 here and F4 here, so done. Get negative 36, right? And let me drag. Okay. So if you notice, the median income was high and it was 70. But remember my model, I used 3 variables. So what you see here is, as I have added 2 more variables, my model, which represents 3 variables, is becoming stronger. Do you see that, there is value in using 3 variables instead of 1 variable? Yes, no? Is it clear? Because if I would have used 1 variable, I would have got a correlation of 70.70. Now we are actually using 3 variables in my model. So now I'm able to predict more variance, right? The correlation is 0.72. You know that we are actually getting closer to the actual. Of course, you can argue that it's increased by a very little bit, right? 70 has become only 72. Questions? Is it making sense? Yeah. Okay. Anika is saying we should use R square. Anika, you want to unmute and say why we should use R square, not correlation? You want to unmute and speak up? Anika is there? She's left.
Hi, I have a doubt.
Yeah.
Okay, the correlation, like as per my understanding, is like we need to like find the what is the like relation between 2 variables, but find out like how correct the predicted variables, I mean the predicted value to the actual value, so we can find out the difference between this, or we can use the mean squared error, the MSE.
Perfect. Good answer. So let's calculate error. Okay. Do you want to calculate error square or error, right? Mean squared error, right? So let's calculate error. So what I'll do is I'll take what will be the error? Actual minus predicted.
Yeah, and then we do a square root of this.
Okay. All right. So let's create one more column called error square. So all I have to do is this. And there's a cap symbol and 2, right? You can do that, right? Now let's select both the columns and double click. So you can see here, it did it for all 1500, right? Now this is, what do you call it? For all 1500, right? Second. Okay. Now I go here, I say sum function. I select all the square of errors, right? So this is my squared error. Of course, it's a very, very large number. Increase, decrease, whatever, comma. Right click. Okay. So it's a very large number. I'm trying to put a comma to see if it's more fonts default area, not fonts actually. I want to format it to a number. I think it's on view mode. That's why it's not showing. So, but you see it's a large number. But if we actually improve the model, you'll see this error go down, right? How do you improve the model? We include more variables, right? That's what we learned. So if I want to add a which variable, you can clearly see that this was 70, this was 5, and this is 1, right? Did not add much. This is 4, not much. 16, okay. -5, not a problem. 36 and 23 seem to be two good candidates, right? So what if we, instead of using this population household, which is only 5 and 0, 1, instead of that, can we do longitude and latitude? Intuitively, right? So if I actually want to maybe insert a couple of rows here, columns here, okay, and I want to copy latitude and longitude and bring it here. Okay, so let's say Control C and come here and Control V. Okay, and now these are my new X1 and X2. Okay, so what I want to do is, of course, a lot of things have changed. So I want to remove my prediction, let the error be there, no problem to calculate error square. So I want to update my regression equation now, right? So what I'll do is, okay, so I kind of change now. So, okay. So now let us see, and I want to use linear estimator of my Y, of course, is this one. But now my X, X1, X2, X3 would be latitude, longitude, and income. Okay. And we want to estimate only the coefficient, but not values. If we do that, you can see here. Now you get a different model, different estimate, right? Now let's calculate the prediction. Now prediction will be what? Intercept. We already know it is F4 plus the slope for X1. So I have to put constant times X1. X1 is which one? Longitude, right? Then I have to take the slope for X2 multiplied by latitude plus slope for X3 times median income. I got a prediction of this. Did I get 3 variables here? R4 to H, R4, H. Then we are taking Q4 times I and P4 into this. Okay, now I calculate everything, error square. Of course, I didn't keep the old value, but remember it was starting with something 4, if you notice, if you remember. Now, if I don't even remember, let me find the correlation between actual and predicted, right? We remember last time it was 0.772, right? Now let us see what the correlation between predicted and actual now. So predicted is this, and the actual is this. So before I hit enter, any guess what you expect? Do you expect it to increase from 72 or reduce from 72? Do you think our model is good, better? Then it will be higher. Does it make sense? What do you see here? 75.
Yeah.
That means we are able to now explain more and more about the variation in Y. Okay, so this is actually how we'll build a model, right? So initially you remember what we did. We took our dependent variable, which is K, and looked at the relationship between Y versus X1, Y versus X2, each one. So we call that bivariate. That means we're analyzing 2 variables at a time by using scatter plot or correlation. So scatter plot or correlation are tools which only analyze 2 variables at a time. You take the dependent variable and one of the independent variables, right? Now, when you build a model just with the top variable, you get only 70.7, right? Now, one of the person said we should not use the correlation, we should use the R square, which is correct, right? So if you do R square, So what is square of 0.7? Square of 0.7 is 0.49. So that means roughly we're able to explain 49% of the variance in Y. The rest 51 is still error. But the moment we increase, I mean, instead of using one variable, we use top three variables, we are able to increase our correlation to 0.75. Now, what is square of 0.75? If I take this and square it, we're able to explain 56% of the variance in our predicted, I mean, the dependent variable, right? So this is how I would interpret that the model is getting better, but we are able to explain 56% of the variance, 44% is still error, right? So if you see here, my model, right? This is my model 1 using one variable. This is model 2 using three variables. So you can clearly see, maybe, okay, so this model 2, which is using three variables, is actually able to explain 7% more variance, right? Now you may see like, okay, if I keep increasing number of variables, it should increase, right? So this is where, and beyond a certain point, you will add more variables, but they are not significant, then you will not get that lift. You will keep on adding variable, but you will not get a lift. Okay, so this is how typically regression is kind of done, and we should kind of do the diagnostics. We look at how good or bad it is, right? But this is more like a real life example of how one uses regression to So now with this, let me ask a question, right? Can we now predict if I give you longitude, latitude, right? So after I got this, if I give you location of the house and give you the median income of that area, would you not be able to predict what is the average value of the house that is going to sell for? Right? That was our original question, right? So we know our equation is, we'll take base price is -27 plus these are all the coefficients. If we give a latitude, longitude, and the median income of that area, we'll be able to predict the house. So this is an example of practical usage of how one would use regression to make an everyday decision. Yeah. Okay. All right. I think we kind of almost hitting the 2-hour mark here, right? So we'll kind of stop here to see if anybody has any questions on whatever we discussed so far.
Can I ask whether can I ask whether this data has got the area of the house? One question.
Yes. The answer is this data set doesn't have it. It has only a total number of rooms and total number of bedrooms. There are some other data set which is available area. Yes, that can be square foot basically, right? That can be a good candidate. In this data set, we don't have it, but that's usually a good variable we should include in our data set.
Okay. I have another doubt. If latitude and longitude is given one particular point, and say for a radius of 1 kilometer, can we identify the value with this given data? Only creating an interest on the topic. The question is intended to create interest.
Yeah, I mean, the diameter of the world, which is 64,000 kilometers, right? So we know the entire area is pi d. So pi is 3.4, approximately 3.14. So you can multiply 3.14 into 64,000 kilometers, right?
No.
So it's going to be, so even if you are talking about 1 or 2 square kilometer, the latitude, longitude will change in the 5th or 6th decimal point. But if you keep it to 2 or 3 decimal point, it will be very, very close. Make sense?
Okay.
So you can see, imagine the entire California, such a big state, right? I think if I compare California to a state in India, I don't know which one comes close. Maybe like a large state like Chhattisgarh. Chhattisgarh has similar shape like California. Okay, it's a pretty large state, maybe bigger. I had to look at the square foot. It's pretty large state. Yeah. You had another question, Mohanty?
Here the latitude, longitude and latitude that is given, is it a particular point or how do I take it?
Yeah. If you use GPS, you can look at your phone, like, or you go to Google Maps, right? So I don't know if I won't have access to Google Maps because I'm logged on to the what do you call the IIT Madras ID, and it doesn't allow to go to Google Maps.
Yeah, fine,
Yeah.
fine.
But
The
you can
doubt
pick
is,
an address and you can get a lat and long for any particular address. So that's not a
yeah,
problem.
the doubt is the data set does not have the area of the house, one point,
Yes.
and this latitude and longitude looks like a single point.
So it's a
It is not,
centroid. So if I'm taking an area, right, each house has a latitude, longitude. So the way the data has been done is, basically like yes, correct. Essentially a specific point, like, and it is up to 2 decimal points. Yes. So this is specific to the house. If you see here, what are the variables? This is specific to the house. This is the age of the house in years. Like, so the first record, maybe if I look at this record, it's a 15-year-old house. Now, when you see the total number of rooms and all that, right? I think it got little like, what do you call it? Summed up and all that. But usually a particular house would be having 2 or 3 rooms. I think it has aggregated data. That's why we see all these rooms. Okay. But typically, if you go to the raw data, you'll see that it will have unique values, right? So, but these are all.
suppose, how can I check if suppose somebody is quoting very high rate? Can I check the nearby, immediate latitude and longitude nearby?
Correct.
With this data, can I check the value and correlate it for buying?
Excellent question. So if you are a buyer of the house, let's say, right, some seller has quoted a price and the house latitude and longitude and less the median income of that area. By using the regression equation we just derived, you plug in the values, you get the estimate, and you find what they're quoting versus what your regression output is. If the error is very large, you know that they're quoting very high. So this will be one practical usage of the regression equation. So, and if it is much below also, you can see if they're overquoting or underquoting. At least you can use the output or predicted value using the regression as a guideline to determine if the price that the seller is quoting is very high or very low.
Okay.
Makes sense?
Thank you very much.
Yeah. Okay. All right. Any other questions? Anybody? I think it's about 2 hours. Otherwise, we'll wrap up. But I just want to make sure that if anybody else has any question.
I guess there were some questions in the chat box. There were some questions.
There are some questions on the chat box. Okay.
Yeah.
Okay.
Anika has asked that why we have taken the negatively correlated variables for the regression.
Correct. Now, very interesting. So when we are looking at a variable, we don't really care about the sign, because remember, in real life, some variables positively impact the house prices, some variables negatively impact house prices. For example, can we think of, as we increase the number of bedrooms in the house, the price will increase? Can you think of something which will actually negatively impact
age of the house? Age of the house.
Perfect. Good answer, right? So older house. So it is
one more thing.
Pardon? Yeah, go ahead.
Probably the taxes you pay could be less at one place.
Correct.
That
Property
could have
taxes.
negative value. Yes.
Yeah, property taxes. Yes. So
Yes.
in the US or even in India, we have this holding tax or property tax, right? So many times the city or the local jurisdiction sets up the price. If there is a high tax, then it will discourage people to go and buy a home there, because you have to pay a very high tax every year, right? So usually the very high tax will lead to a lower price. So that will be another variable where it will be negative. To answer your question, so when you're doing a correlation, we're looking at the quote unquote strength of linear relationship between the independent variable and the dependent variable, right? The strength is given by the magnitude, and the sign tells us if it is positively correlated or negatively correlated. To call a variable important or not important, we should only look at the magnitude, not so much to the sign. Okay. Hopefully that I think I think it was a question from Srivinay, right? So
It
I
was
think
from
this is
Anika.
why many time we take the absolute value and what do you call it? Like, and sort the data based on the absolute value of the correlation. So when you're choosing, if I got 6 or 7 variables, you first find the correlation, then take the absolute value of the correlation, then you sort the variables based on the absolute correlation. And if you are going to select top 2 or top 3 or top k variables, so you should use the absolute value of the correlation. Yeah.
There's another question in the chat box, sir. It's from Harsh Kaushik.
Yeah, go ahead,
He
please.
says, is this a valid method or not? Write median house value as linear combination of all variables and find coefficients to predict.
Okay, is this a valid method or not? Median house value as a linear combination of all variables. Okay, all right. So what does it mean? So essentially you are taking linear combination. What is the linear combination? Are you going to give equal weightage? Why we should take linear combination or combine? The regression is actually creating the output is actually creating a linear combination, right? Because my linear combination is, if I go back to our output that we got, right, in the, right, this is it not a linear combination? I'm taking some intercept plus slope times the weight. Slope is my weightage times the variable, right? We are actually, the regression is basically nothing but a linear combination. The weightage is determined by the slope, right? So when you're saying you are going to take a linear combination of the data and basically you're combining all the data. So maybe the choice is, if I add x1 plus x2 plus x3, let's call it x4, right? And then I will only have one coefficient. So that means I'm forcing the slope to be same for all variables. Isn't it not true? Because if I take beta times x4, it is equivalent of beta into x1 plus x2 plus x3. That means I'm using the same beta for each variable. So that means I'm treating all variables equally. But you notice that when you look at the correlation, each variable's strength of relationship with the dependent variable is actually different. So that tells us intuitively that we should not be using equal weightage for each variable. Depending on the relative importance, we should be increasing or decreasing the weight. And that is what is actually the output of the linear regression. Okay, so I think that's intuitively, whatever is more important, it will be given more weightage. That is why our model will be more stronger. So if you notice, we used initially median income and household and population, right?
Right.
So the top variable is there, but something in the serial number 6 and 7 we picked. So the model was increased from 72 to 72. The moment we picked two stronger variables, you would see the overall model strength also increased, right? That just proves us that by using stronger variable and giving more weightage to those will improve our regression. Yeah. Hopefully that is making sense, right? So I think some of you will take machine learning foundation in a diploma level or machine learning theory, right? So whatever we cover today is basically a very basic foundation. I'll talk to sir, we'll probably cover more. We'll get into the details of matrix notation, how to formalize the mathematics behind linear regression, right? We'll probably cover that in later sessions. But today was just basically very introduction to, before we get into Python, because we may have some foundation students who have yet to take Python or getting it. So many times let the tool not come in a way of learning, right? We all know Excel or Google Sheets and all that. We have all got access. We don't have to buy Excel. We can use Google Sheets or WPS, which is one of the free software that is available in the market. Download it and you can practice. You can take a smaller data set like California housing data that I shared, and you can try to replicate what we did in today's session, right? And if you have got any questions, you can definitely post it on the Discord server, and I'll be checking and we'll answer, and maybe we'll kind of cover it in future sessions as well. Okay. All right. Anybody else has any questions before we wrap up the session? Very good. All right. I wanted to thank you very much. I know it's pretty late, pretty late for dinner, but really appreciate your patience, and hopefully we covered some basics, and we'll cover more interesting concepts in future code session. Thank you very much, and have a very good night, all of you.
Thank you so much, sir.
Thank you very much. Good
Okay.
night.
Okay. Thanks a lot.